one last keynote speaker for the day. Our last keynote speaker is Dr. Lorenz Meier, chairman of the board of Drone Code Foundation, founder of PX4. Lorenz is the founder and CEO of Auterion, as well as the founder of all of our open source projects, and the creator of the PX4 Autopilot. So Lorenz has received several awards of his fellowships for his work, including being recognized by MIT Technology Review as one of the top 35 innovators under 35 in 2017. Please welcome Dr. Lorenz Meier to the stage.
Good. So who else is only at the conference for the drone light show? Awesome. So as we get going.
Thank you.
Yes, we do. Awesome. The theme of my keynote is actually pretty similar to what you just heard, namely that looking a little bit back, but also looking forward even on a higher level than the day-to-day that we're sharing. And I was trying to figure out how to get this point across, because it seems like we're at this now. I'm at this for 15 years. It's a while. And I thought yeah, let's look at the drone industry. And then I thought no, you actually don't learn anything, because we need to relate to something that has reached steady state, because we don't have just yet. And so I'm going back to cars, because that's a good way. I could have chosen airplanes the same way, but you kind of can see it physically almost. And as I did my research for this talk, I looked actually into something that is interesting. Before cars were called cars, they were called horseless carriages. Makes sense, right? Because that was the default. And we call this uncrewed system. That's funny. So maybe drone is the word, maybe not, but as long as our industry is calling itself the unmanned systems industry, we're not there yet. We're really not there yet. We're still in that horseless era. And there were hundreds. Actually, in the US, there were over 5,000 companies doing horseless carriages. And they were all a bit wonky and partially worked and sometimes didn't work. And that was actually 1893, way, way, way before the real passenger cars. And then, depending on who you ask, I'm sure you get a different answer. But one of the first cars that is being credited with having achieved product market fit, but being way too expensive, was the initial Mercedes with 35 horsepower, which was a lot back in the day. And there are a bunch of other vendors. That was already 7 years later. So we're kind of now, when we look at the drone industry, we're somewhere in 2015, 16-ish, and that kind of makes sense. Now, the problem with that thing was it was way too expensive. Way too expensive. They only made a few of them. And then Henry Ford came along and nailed it. Nailed manufacturing, repeatability, cost. And that was, I think, overall 15 years later. And 1908 Model T, that's still not mass adoption. Just look at how you crank up the engine. Not quite there yet. But what's important to me is, there are mass manufacturers like DJI. Let's not forget that. But if we look at the commercial industry overall, we're somewhere here, or maybe slightly before that. But we're not at the level where a car is a normal thing yet, or a drone is a normal thing. And so my mindset is very much to really think about this humble time we're still in, to not get too specific about the problems of today, because they will go away. We still have problems of tomorrow to solve. And to encourage you all also to think a little bit okay, we seem to be still in a state of infancy. What does that mean for the industry? Well, it means we need to focus on growing the market, not competing with each other. And I think we're one big family here, but even if you think about DJI or other proprietary vendors, our ambition can't be to displace proprietary vendors. Our ambition here has to be to grow this market into a size where it is a mass market, and it is just not today. It is not yet. But we're also not very far away. So we're at this very interesting inflection point. And I want to just make a couple examples that we're somewhat close to and have insights in. Walmart is adopting cargo drones. And why is that significant? Well, it is significant because they're putting their weight behind it for consumer deliveries. There have been cargo drones before. Zipline is, to me, the unquestioned leader in the space. But this is a new dimension. This is a sign of initial mass adoption. And maybe it is initially not successful. Nobody knows, right? But the fact that companies like Walmart are now trying, big, big difference to the early cargo drone efforts that are going on for the past 10 years. And then the other sign is, in this case, I picked the FreeFly Astro, is standardization. Standardization of the payload bus on Astro. So Astro is the first drone that has a Pixar payload bus integrated. And that will change how we adopt technology, because now you can take a gimbal from a different drone onto this model, and it will just work. And of course, we will initially fail in some of the standardization efforts. Like, we will have minor issues, and we'll work through them. But why does that make sense? That's a great example of co-opetition, because you could think like FreeFly is crazy to open up their vehicle for third-party gimbals. Well, they're not, because they have the best integration for their default gimbal, but now people can bring other cameras, other gimbals. So what happens? FreeFly sells more drones in aggregate. And that's really the mindset we need to be successful with open source adoption. So we're starting to have these really product market fit, real products with smart batteries, with everything you're looking for. And to me, that's super exciting. But what are the main areas that we need to work on? And I think what we need to work on as a community is three main things. Modularity. PX4 is very modular, but we've grown individual modules, like Navigator, for example, to a point where it's not really modular anymore because it's so big that it does too many things. So we need to work on that to enable more companies to integrate, and also I will come later to the points to adopt in the right way. We need to move to distributed PX4 because the mission computer is part of the canonical device going forward. The times where we run on a microcontroller are drawing to an end, and that's a very good thing. The microcontroller will not go away to me, but it's not going to be the only processor in the system. And then we need hardware standards, because hardware by now is more than a microcontroller and a bunch of sensors, so it has become so complex to maintain, to build, to design, that if everybody does their own hardware, we're not getting anywhere. The economies of scale do not allow that, so we need to standardize some parts of the system. And so let's look a little bit at what that means. It means we can have search and rescue and other reconnaissance applications with drones running this. We can have cargo. This is just one example. So there's so many products, and I, on purpose, also chose products that are not on the market anymore, like the GoPro Karma, running PX4, because we're just going through this phase of the industry where there's initial success, initial failure, the same way as there was in the car industry, but what stays is the technology that we're building together. We're also venturing into new areas. I don't know how many of you have even tried or seen that, but this is two things that most of us don't do every day. One is rovers, crazy, and the other thing is multi-vehicle control from a single ground station. really things that we're getting into. We're getting into swarms. It's normal. We're getting into all of that. So where do I see the inhibitors? And this is, most of you will already be aware of that, but maybe I'm giving you a mental picture how to take that to your company. So where does open source adoption fail in general, but I'm also seeing this in our community? Let's start with the steady state, upstream PX4 release, simple, bunch of stuff, cool. Now you come and you add something, and in many cases what you add as a developer representing a company is a mix between improvements, bug fixes, and features you're building for your company, sometimes even including intellectual property. And very often it's not even clear where intellectual property starts and ends, and where differentiation starts and ends. And so all of this could be potentially IP. All of this could be potentially something your manager cares about. It's all mashed up. Okay, you add that. Now what happens is we have an upstream update that does maybe something similar. And now two things happen. One, it explodes here because you can't merge it anymore because you've sprinkled your changes all across the system. But also, in order to resolve it, you would need to upstream stuff, and now you need to decide what is actually differentiation and what is not. And then you end up in this incompatible space where you can maybe cherry pick a few patches, but it's very hard for you to tag along. I've seen that so many times over the last 15 years. So I think most of the friction we have in open source adoption, I will make the argument, not in PX4, but in any sort of open source project, is through hitting either the limits of architecture or not spending enough effort in thinking through it initially, and or the lack of clarity of mind. What is infrastructure and what is your product? So it is between you, your product manager, and your top-level management to resolve that. It's not just a technical problem. And so most of the conversations we have is where people say, like, yeah, we need to upgrade. We haven't upgraded in a year. And yeah, I need to talk to my manager. It's an accident. It's not by choice. And now you could think like, oh, if we had a way to force the companies to give up all this and do it with a license and they have to upstream everything, well, I don't believe that to be the case. I mean, we're pretty successful in building open source driven avionics and autopilots with PX4. It works. And I don't know if when you have set up your last router, but they're a mess. They're even more a mess than what we're building here together upstream, because they take Linux and then they throw a UI on top of it. They don't know what they're doing on average about cybersecurity. And I mean, that's all copyleft code. So they provide the zip file. You can download it on the FTP, and there are great projects like OpenWT and other things. But they're not the default that are shipping with the products. So it's actually not working. That whole router thing is, from a community perspective, not working. Companies are not shipping the good stuff, and they are not collaborating. So I don't think it's a license question. I think it is very much an industry organization question, and that's why I'm focusing on this so much today, because it depends on how you talk to your management and how much understanding the participating companies have. So let me go into what I think can be a successful adoption lifecycle. And it starts with having clarity of mind. What is infrastructure that the open source project provides? That's on the bottom. What is infrastructure that you need to develop because it's out of scope or just not there yet? But infrastructure is still not differentiating. It's not something to keep to yourself as a company. And then there are the true differentiators, and there's so many differentiators. There's software, there's hardware, there's a service, there's a user experience, and there's, quite frankly, brand. Sometimes the best differentiation is brand. You're not trying to do something fundamentally different. You're just trying to have the most trusted product in the market. And whenever a company has clarity of mind, that's my personal experience, on these layers, it's very easy for them to adopt open source software. And whenever they see they're crossing a layer, they know they have to build an API. They know they have to build an abstraction, and they will be able to continue to upgrade from upstream. So I think this is really the most important aspect of successful adoption. It's clarity of mind. It's not a technical problem. And then the other part, and this is coming increasingly into the industry, this is a software-defined industry, so the end customer of all of us jointly here, they really don't want 5 different operating systems. They want something they're used to. I mean, they want something like PX4. But on top of that, they also probably don't want your very special version of PX4. They want a recent release that they maybe have cybersecurity audited already. So the fact that it's based on open source is not enough to them. It needs to be something that they can actually qualify. We haven't seen a lot of these asks before, but they're coming now very fast from large organizations. So a large cargo drone deployment, a large government drone deployment. These customers have soldiered through having a mess in their IT infrastructure before. They know what it means to not control this, and they will drive more and more towards that baseline. So that actually helps with open source adoption. And it helps if somebody asks, like, hey, can you give me a cybersecurity qualification? I mean, it's not like not every drone company will do their own cybersecurity qual. It's just not possible. It's too expensive. And so it leads then to the fleet view, and these are just a few of them, but these drones are all running PX4. They're all part of the one fleet. They're all running the same baseline. They all can be interfaced with the same version of Mav SDK. They all can run against the same ground station. And it's just an example, right? But that's how the customer sees it. That's what they see when they look at drones. They don't look at the individual model. They increasingly look at, what is my fleet? So that's also very important, because the companies that will stick around in this industry will be the companies that can be part of a fleet. So, and then the other part is, I mean, as I'm talking to CEOs about open source software, a lot of them understand it's like free stuff that you can pull. It's good joke, right? But in order to be long-term successful, you also need to be comfortable with something that is called co-petition. As a company, as the CEO, you need to be comfortable. And the typical question is like, hey, if my guys improve this and that, and something low level that no customer ever cares about, like a controller, then my competitor will have that controller as well. And so their stuff will fly as well as our stuff. And it's like, yeah, it will. A little later, because you're going to be first to market, but the benefit to you is that you get all the other things, and by the way, you got a lot of other things when you started with this, and you're not diverging. And not diverging is the important thing, but that's extremely hard for people to wrap their head around. And I think like typically 10 years is one professional generation. So you're basically doing something for 10 years with people, and then as you cross the 10-year mark, you have the next generation, because people haven't come of age with this stuff. And so I'm finding myself, for the last 2 or 3 years, suddenly having the same conversations again as in 2014. And I only realized recently that that's actually happening, and why this is happening, and what's going on. So I think that's also, in particular for the ones here that are more familiar and really understand what we're doing here together, don't think that the rest of the world does. And don't think the fact that the drone industry is built around open source software means that it's actually widely understood. So we all together here have a lot of education work to do, how this works with this open source thing, because if we don't, the default that the world will fall back to is, yeah, it's free stuff, and then you end up with this funny divergence. So then one more thing, and I hope I start a little bit of conversation here, because I think some of you will be on this side of that conversation, and some of you on the other side, which is, from my perspective, from a maintainer perspective, modularization to make it easy to integrate different things is not the job of the upstream team. And the typical conversation goes like that. Somebody shows up out of nowhere with a really cool pull request that's hitting 20 different files and is adding something. And you look at it and you go like, yeah, this is kind of cool, but it's competing with this other thing, maybe with a different vehicle type, and it's going to explode. So we actually would need to first tear down parts of the architecture to really accommodate this in the right way. You get that as a feedback in the pull request, and the answer is like, oh, I don't have time for that. Why are you rejecting my contribution? Almost to a point of like, why are you dismissing me? It's not what people write, but I can feel it between the lines. The problem is, if that becomes the problem of the upstream maintainer team or maintainer, that's suddenly so much work. And you have to imagine, like, I know the code base still pretty well. Daniel knows the code base like his backyard, probably better than his backyard. So, but still, you have to switch context. You have to dive into this. You need to think about the side effects. Most likely, the contributor of that pull request actually knows better what's going on there. And so I would push back and say, like, no, that is not the problem of the open source project. That is the problem of the contributor. And it can mean that for a 20% contribution, you need to do 80% re-architecture. But believe me, it's worth it. And you need to plan for it. The same way as in modern day software development, you do plan for testing, you do plan for CI, you do plan for cybersecurity efforts. And we all understand that writing the actual code is just a tiny, tiny piece of getting a new piece of functionality in. So food for thought, hit me up throughout the next 2 days. What do you think about that, and what your internal conversations are that you're having? I also want to look a little bit forward, not just like how do we get better contributions, and really point out, and this is just one image, could be from Qualcomm or anything else. The mission computer is the next frontier. That's the next frontier. And our architecture has been evolved over the past 5 years towards that goal. So that's not the new direction. It's not a surprise. But I just want to put this squarely on the center of the table here. This is important. And you need to shift how you think. What runs on the flight management unit? What runs on the mission computer? And that PX4 has to turn into a federated system to do that. There is and will be a Mavlink scope increase. And what I mean with that is it has been built for a certain era, but now we start to have video, AI, all sorts of stuff. And we've been very successful in shoehorning it in up until now, but we need to start to think that we're not digging our own hole here. And what does that mean for the transport layer, for the comms layer? I think that the way we're doing Mavlink messages for what is, that will not change. The content will not change. The semantics will not change. But we definitely need to look at transports, at discovery, at networking, at going from 1 drone, 10 drones, 200 drones to, hey, I need to talk to this drone in North Carolina right now. How do I reach it? That's going to be the problem. And right now, every company is solving that individually, and I'm seeing all sorts of techniques like MQTT, AWS, I forgot the product name, but has a tool where you can reach individual systems, and they look it up, they kind of do all that. VPN, zero tier, your technique of choice. But that's not scalable. We need to solve that here, in this room, properly. And with that, I've kind of already hit that point. Like, think of drones as networks. Think of them as nodes. Think of them as something that's online. And I don't think it will shift the focus of PX4 to networking, but it is the context that we're operating under in the future. And that also will mean that drones will become more and more part of critical infrastructure, of inspection, that a survey like this in the future won't be done by somebody driving up there and launching the drone and whatnot. So, I mean, and then also being online, you know, I'm not saying everything will be a drone in a box, but it should be easy to build a drone in a box solution out of PX4 as a default tooling. And it should be pretty obvious going forward. To achieve all that, because what I just said is a massive scope creep, massive scope creep. Well, we need to do less individually. And that means we also need to standardize hardware, because otherwise we'll end up in a situation where it's just unmaintainable, completely unmaintainable. And so look at these standard documents, engage, because you need that to reduce your own scope to where you can excel, where you can integrate, where you can add value, and where we as an industry can share more workload. If there are any questions out of the audience right now, I'm happy to take them. Very often people are very shy at this size of room. Go ahead.
It's my first time here. I've never met any of you guys. Just wondering how many of you are from Texas or Austin? Like how local is it? How international? So, you raise your hand from Austin or Texas? Can you repeat the question?
Yeah, I can quickly repeat the question from the audience is how many folks in the audience are from Texas or the area? And I saw like maybe 8 or 10 hands, something like that. Maybe a little bit more? Okay, it's more. It's more. 12, 15, something like that.
Thank you.
Next question. Yeah.
So you referenced standards with TikTok, which I think is great, wonderful, and I'm curious, have you had any conversations or dialogue with the FAA on an approach for certification of some of these open source hardware, software implementations? If not, I mean, is there interest for that? Or like, how do you see moving forward, bringing in some of these, you know, kind of aircraft aviation systems into the current regulatory process? And I guess for more than just the United States, right? EASA or other organizations.
Okay, so I'm going to quickly recap the question. The question was, with respect to the standards that we just discussed, how will they get certified, or what role will they play in certification and acceptance into airspace? So yes, big part of the reason why we're doing these standards are basically safety and security, cybersecurity. Because the burden of certifying for airspace and the burden certifying for cybersecurity will exponentially grow over the next couple of years. In particular, if you operate domestically cargo drones or something like that. I mean, your risk exposure is like massive if you fly over suburbia from a legal perspective. And so I think what will happen is that this will drive consolidation for some of these components in a way where in a year or two, you could design your own flight management unit, your own FMU V5 or V6X. You could. It's not impossible. You could manufacture it yourself, but you're not doing it because the FAA tells you, oh, show me your manufacturing certificate. Show me that this went through this. Show me this for your design. Show me the flight hours. And then you go like, oh my God, like that alone is more than my whole engineering budget. And so like in the automotive industry, I expect vendors, individual vendors to emerge who take that burden on themselves, and then people start to buy from them. And you know, it's an open standard, so it's not like it will become a monopoly. If you have the means, you can still do it yourself. If they hopefully have a competitor who does the same thing, but there will be certainly convergence onto like less people doing that kind of work. I think the same will be true for software. There will be certain software releases that have gone through a certain qualification, and we'll provide a baseline with PX4 upstream, but we can't do everything. Like nobody will pay us for that. So it will be the same thing where software releases will get qualified by some companies and maintained, as it is the case, like Red Hat, great example for Linux, has all the cybersecurity qualifications already for certain things, and if you install Red Hat Linux, you know, okay, that's going to be accepted. So that's why we're driving strategically towards standardization, because if we don't, then what will happen? What really will happen is that no drones will be adopted because they're still so expensive and such a niche that we never get to that massive Cambrian explosion that I think this industry is ready for. Yeah.
I'm wondering, as a CEO, if you could unpack the topologies of competition as you see it. Do you envision something where companies are contributing to maintainers that are doing it not for profit, or do you imagine those companies in those spaces becoming maintainers and growing space that way?
So the question was what types of co-petition we can think of and how that works. So abstracting it a little bit away and looking at what I've seen in this industry, but what I also have seen in other industries is, so what typically doesn't happen is that everybody chips in, you know, a coin and then you pay 30 maintainers and they do it for everybody. And why does that not work typically? It works long term, but it doesn't work on a time axis because each company has a certain level of urgency for certain things. And so if everybody just contributes to a big maintenance team, how do you agree on priorities? It becomes incredibly hard. So what most open source communities have adopted is a little bit different. You have a handful of maintainers, 1, 2, 3, not more. Like the full-time paid Linux positions are, I think, really 2 or 3, handful, that moderate everything. You need that. You need moderation. But then the maintenance is with individual people that work for individual companies. So you have in the maintenance team of Linux, I'm sure somebody from Google, I mean, not somebody, like, I don't know, 100 people from Google. Same thing from Red Hat, same thing from others. And what they do is they spend time on maintenance, but I would say prioritized with what their company needs. So if their company is very concerned about cybersecurity, they're going to focus very much on cybersecurity. If their company is very much focused on latency, they're going to be very focused on latency. And we're starting to see that emerge in our community as well. We have maintainers that have certain focus areas. I mean, Auterion is paying a lot of the maintainers. And the relative urgency is around the things that the adopting companies, that the customers need. And so that's a simple way to solve it. And it's modeled after what we've seen in the Linux space. So it's not like some new idea. And in terms of co-petition, I find that for the companies that are very, very clear, that have clarity of mind, who they are, how they differentiate, they're really easy. They're at ease with talking to competitors, for example. But whenever it's not fully clear yet, and in the early days of forming a company, that can be incredibly hard. And yeah, I think you know, this is a good kickoff of the discussion, but that's also a lot of work that I want to spend time on this year because I see that right now as a big inhibitor for the whole industry, like not even just PX4, because we need to overcome that. And again, I've seen the same thing in the Linux space, I'm talking a lot to folks from Red Hat and asking them about their experiences. And they're saying like, yeah, they had discussions with banks that had their own Linux distro just 10 years ago. Like there were literally banks with their own Linux distribution. And yeah, because they needed it differently or it made them so much better. And you think like, how does this even relate to your core business? So the problems we're facing are absolutely not new. Go ahead.
Could you expand more about the Mavlink scope increase that you were talking about? You did mention that people are passing around MQTT messages or, let's say, their own kind of custom protobus, and I was kind of hoping you could dial it in as to should we be passing from Mavlink messages? Should we be having companies maybe expand their own custom Mavlink?
So yeah, so the question was, could I dive further into what I mean with Mavlink scope increase? I'm on purpose staying away from that because, not because I fear the topic or because I don't have a personal opinion, but we've now reached a size as a community where it's really important for the leadership of the community to take a step back and leave certain areas to the key architects in that area, and not to top-down start to, chart a path. I mean, we probably have to be the arbiter at some point where people say, I want to left, or like, where do we go? You need the benevolent dictator at the end of the day. But I don't think it should start with seeding the solution path. But what I can definitely say is this is a very active conversation and one that we probably want and should be driving to a conclusion sooner than later. But that's going beyond PX4. It's other open source projects. It's proprietary vendors that are part of that. A lot of the Mavlink standardization effort has been funded by the US government as an investment, like in the early internet, in fundamental technology. So the US government is a stakeholder. And so I think it's really important to have it in that circle, and to not show up at any conference and say like, hey, this is what we should do. So I'm not trying to dodge it, I'm just trying to show humility.
We're running out of time here. Thank you, Dr. Lorenz Meier. Applause.